Have you ever stared at a photo from space and wondered what those giant, glowing clouds actually are? Some blaze bright pink, some shine electric blue, some look like black holes torn into the sky, and some are so massive they're building thousands of stars at once. Here's the strange part. They all look like colorful clouds, but they couldn't be more different. Some are nurseries, some are graveyards, some emit no light at all. Fly through the wrong one, and you might not even notice you're inside it. Most nebulae are thinner than any vacuum we could create in a lab. Yet these ghostly clouds built almost everything you see in the universe. Stars, planets, us. So today, we're breaking down every major type of nebula, from the glowing nurseries everyone recognizes to the invisible giants hiding astronomy's biggest mysteries. By the end, you'll understand why every star you've ever seen began life inside one of these clouds. Emission Nebula. Picture a giant neon sign flickering on in the dark. Instead of electricity, the power source is newborn stars. These clouds are mostly hydrogen gas, and when massive young stars ignite inside them, they unleash ultraviolet radiation that strips electrons off the hydrogen atoms. As those electrons fall back into place, they release light, and the whole cloud begins to glow, usually in brilliant shades of pink and red. The Orion Nebula is the classic example, one of the closest stellar nurseries to Earth at about 1,300 light-years away. Thousands of young stars are forming inside it right now, and as long as new ones keep igniting, the nebula keeps shining for millions of years. But not every nebula makes its own light. Some simply borrow it. Reflection Nebula. Imagine walking through thick fog at night. The fog doesn't produce light, but shine a flashlight through it and the mist glows. That's a reflection nebula. Tiny dust particles simply scatter light from nearby stars, the same way Earth's sky scatters blue light during the day. That's why these clouds often glow blue. The nebula around the Pleiades star cluster is the best known example. Astronomers once thought these stars were born inside the cloud, but they're actually just passing through it, like a car driving through fog with its headlights on, reflecting someone else's light, not making their own. But if reflection nebulae glow by scattering light, what happens when a cloud blocks light instead? Dark Nebula. Imagine a hole cut straight into the Milky Way, not empty space, but something enormous blocking the view. That's a dark nebula. Clouds so densely packed with dust, they block the stars behind them, appearing as black shapes against the galaxy's glow. The Horsehead Nebula is the famous example, not a horse made of gas, just dense dust silhouetted against a glowing nebula behind it, like a mountain at sunset. Dark nebulae may look empty, but inside them, gravity is slowly pulling gas together. Temperatures are rising, and eventually stars ignite from within the darkness. Ironically, the darkest places often birth the brightest stars. But starbirth is only half the story. Every star eventually dies, and how it dies decides what kind of nebula it leaves behind. Planetary Nebula. Despite the name, a planetary nebula has nothing to do with planets. Early astronomers just thought these round glowing shells looked planet-like through small telescopes, and the name stuck. What you're really seeing is the final breath of a dying sun-like star. After billions of years burning hydrogen, the star swells into a red giant, then gently blows away its outer atmosphere, layer after layer, like smoke from a campfire. What's left is a small, blisteringly hot core that floods the gas with ultraviolet light, oxygen glowing teal, nitrogen deep red, hydrogen pink. You're reading the star's own chemistry, written in light. The Ring Nebula and the Helix Nebula, the Eye of God, are famous examples. These structures survive only about 10,000 years, barely a blink on the universe's clock, before fading into space. Not every star dies this peacefully. Supernova Remnant. Imagine compressing something many times heavier than our sun, then releasing all that energy in one unimaginably powerful explosion. That's a supernova briefly capable of outshining an entire galaxy. The blast wave races outward at millions of kilometers per hour, hurling gas, dust, and atoms across space. This expanding debris forms a supernova remnant, violent, chaotic, and glowing for tens of thousands of years. The Crab Nebula is the most famous, born from an explosion witnessed on Earth in the year 1054, and still expanding today. At its center spins a pulsar, a city-sized neutron star acting like a cosmic lighthouse. More importantly, Supernovae forge nearly every heavy element in your body, the iron in your blood, the calcium in your bones, the oxygen you breathe. Every supernova is both an ending and a beginning. But sometimes, a massive star starts shedding material long before it explodes. Wolf-Rayet Nebula. Some stars don't wait until death to start throwing themselves apart. Wolf-Rayet stars are among the hottest, most extreme stars known, with surfaces beyond 100,000 degrees Celsius, blasting millions of tons of gas into space every second. Winds moving at 2,000 kilometers a second, fast enough to peel a star apart from the outside in. As these winds slam into older ejected material, they sculpt glowing bubbles and shells, like the Crescent Nebula, whose arcs are shock fronts where stellar winds collide. These nebulae don't last long, because the star powering them is usually headed for a supernova soon after. Some dying stars skip spheres entirely. Bipolar Nebula. Instead of expanding evenly, some stars eject material through only two opposite sides, like squeezing a balloon in the middle. A hidden companion star, spinning core, or magnetic field can funnel the gas into two lobes. The Butterfly Nebula looks like glowing wings. The Hourglass Nebula looks like twin cones of light carved into space. Even dying stars don't always follow simple rules. Everything so far ties back to a single star. The final category is bigger, older, and far more important. Molecular Nebula. If Emission Nebulae are maternity wards, molecular nebulae are entire hospitals, the largest, coldest, most massive nebulae in existence, some stretching hundreds of light years, holding enough gas to build millions of suns. They're nearly invisible, sitting just 10 degrees above absolute zero, detectable only through radio and infrared telescopes. Inside them, molecules survive and combine. Hydrogen pairs up, carbon monoxide forms, water and organic molecules appear, building the raw ingredients for future planets and possibly life. The Taurus and Perseus molecular clouds are two well-studied examples, both quietly forming new stars. Gravity, shock waves, and colliding clouds eventually compress a region enough to ignite a new star, and that ignition changes everything. H-time regions. The instant a massive young star switches on, it doesn't just light up its surroundings, it detonates them. Ultraviolet radiation strips electrons from every nearby hydrogen atom, creating an H2 region, glowing gas that can shine for millions of years. Many famous emission nebulae, including Orion, are actually H2 regions. This radiation also sculpts the cloud, carving giant pillars and hollowing out cavities like the pillars of creation inside the Eagle Nebula, slowly eroding under the radiation of the stars they helped create, like a sandcastle disappearing under an invisible tide. Eventually, the stars blow away the remaining gas entirely, leaving behind a fresh star cluster, Protoplanetary Nebula. Despite the confusing name, this has nothing to do with forming planets. It's a brief pause between a red giant and a planetary nebula. The star has shed its outer layers, but its exposed core isn't hot enough yet to make them glow. For a few thousand years, barely a breath cosmically speaking, the cloud just sits there, faintly lit, reflecting borrowed starlight. Blink and you'll miss it. Because it's so brief, protoplanetary nebulae are among the rarest objects ever cataloged, and they reveal how the rings and jets of later planetary nebulae first take shape. But while one star is dying, others are just beginning their own planetary systems. Proplyds. Look closely inside a stellar nursery, and you won't just find newborn stars, you'll find tiny disks of gas and dust spinning around them, called Proplyds, short for protoplanetary disks. Picture Saturn's rings, thousands of times larger, packed with enough material to build entire worlds. Over millions of years, dust grains collide and stick together. Pebbles become boulders, boulders become planets. The Orion Nebula alone contains hundreds of these disks, quite possibly building solar systems that will one day resemble our own. Every rocky planet, every gas giant, every moon began as grains drifting inside a disk like this. Nebulae aren't just beautiful cosmic scenery. They're the universe's recycling system, its construction sites, its graveyards, its nurseries. Some spend millions of years quietly building stars. Others mark the violent deaths of suns that scatter the elements for future planets. Some blaze across the galaxy. Others hide in total darkness, waiting for gravity to start the cycle again. And here's the part that should stop you cold. Every oxygen atom you breathe, every carbon atom in your body, every calcium atom in your bones, once drifted through a nebula like these. Long before Earth, long before the Sunday, we were part of one of these clouds too. Stars become nebulae. Nebulae become stars. Stars build planets. And on at least one of those planets, they built us. So the next time you see one of these glowing clouds in a telescope image, remember, you're not just looking at something beautiful. You're looking at where the next chapter of the universe is already being written.